Alright, y'all, we're going to hop into some probability notes. You should have this sheet. On the back of this sheet should be a bunch of practice problems that we're going to do in a little bit. But looking at this first one, so like starting going through our notes, we have fill in the blank notes today, so hopefully that makes our lives better or worse, or however they will be. Anyways, so probability. And so we worked a little bit yesterday with probability where we're having like groups and we're picking out lemon and cherry, little things from the group, candies from the group. We're trying to find the probability that it happens, okay? So what we're looking at is we're looking at like the group, so that entire box there, you could either have a lemon, a cherry, or a grape, right? And so that was like a group of objects, okay? And what we're going to talk about today is how we notate this, okay? So yesterday we can just talk about 5 lemons, 3 cherries, and 2 grapes, or whatever it was. Today we're going to talk about notating it, okay? So we can designate any group as a set. So any group of objects that we have, any section of things, we're going to talk about it as a set, okay? And sets are written with curly brackets. There's how I look on the computer. Whenever I'm drawing it myself, I'm just going to start at the top, come down, almost making a C, jut out, come down again, and make another C. Feel free to practice that a few times because it takes some practice getting used to it, okay? And so when we have a set is like the collection of all the things in it, all right? It's the group of all the thing in it, okay? And so like the set of odd numbers between 0 and 9, okay? So to start our set, we're going to start our bracket. So 0 is not an odd number, but 1 is. So we're going to put 1. And we're going to separate things with commas. Then 3 is also. And we separate with another comma. 5 is also an object in the set. It's something in the set. 7, and then 9. So 1, 3, 5, 7, 9 is our set. You notice we just did commas all the way through. We didn't put any ands or anything like that. And we put our bracket at the end. Sets can be other things like colors or things like that. Grades in high school. We'll draw our fancy little bracket. There's 9th grade. There's 10th grade. There's 11th grade. And there's 12th grade. And you notice we're just separating things by columns. We're listing it out. And what this does is if someone else came up and looked at this, they know we're looking at a set. And we're like, those are the things in that set. 1, 3, 5, 7, 9 are our options in this set. 9th, 10th, 11th, 12th are our options in the set. Okay? So that's just like a basic thing. And so you'll have some things that will say like, what is the set of such and such? What is the set of such and such? You'll be able to write out the set with the brackets. Be fine with it. All right. Going on. We have probability, okay? We don't want to have to write out every time the probability of drawing a green candy, probability of drawing a grape candy. That's really long, okay? So what we want to do is we want to abbreviate it, okay? So probability notation, whenever we're writing it out, is just going to be a P for probability, open parentheses, and then what's happening, okay? And so it might be the probability of drawing a grape candy. Probability of grape. Okay, and you can abbreviate these as long as it's clear which one's which. And so like we don't have to say probability of drawing a grape candy. We can just say probability grape. Doing the same thing. For drawing an odd number, what's the probability? It's odd. Okay? Probability of event A happening. Okay, so we're just going to say probability again, open parentheses, of A. We can do ORs, which means we're having words inside it. So picking option A or B, we're looking at the probability of A or B. And this just makes it easier to read. Instead of having to write out probability of picking option A or B, we can just say probability of A or B. Everything but A. Okay, you might have picked this up from yesterday from the worksheet we were doing, but whenever we're doing everything but, this is a like not A. So probability of picking not A. Probability of picking something that isn't A. And write that with a, so we have our A and we have a little prime number here. That prime means not, okay? And so the probability of picking something not A is probability not A. And that's what that little apostrophe is, and that's just a quick way to be able to write it out. So, feeling hopefully okay with these notations, excuse me. Ooh, sorry. All right, so moving along. When we're looking at probability, we have to first look at the sample space, okay? So the sample space is everything that can happen. Sample space, so yesterday the sample space that we had was lemon, grape, whatever the other flavors, cherry, lemon, grape. It's everything that can happen, okay? And so the sample space is the total range of values. Sample space is the total range of values that can happen in a whatever we're doing, okay? So if we're doing like the probability of you making 3 free throws in a row, the sample space would be you make 0, you make 1, you make 2, or you make 3. Okay? So using sample space and outcomes, we can find the possibility, okay, just by counting. So we can count the number of successful outcomes, or the number of outcomes that reach it, okay? So probability of A, okay, is just going to be the number of A over the sample space. And we did this some yesterday. Let me make that a little cleaner. Sorry, y'all. But the probability of A is just the number of A divided by the sample space. And so whenever we're doing this, we have to be able to count the total number of other possible things. And so yesterday, we did that by just counting the number of candies. But whenever we have something a little more complicated, a little less given to you, you have to be a little more creative. So flipping a coin 3 times, starting here. So one way to find a sample space, okay, so to find all the possible outcomes, to count all the possible outcomes, is to make a tree diagram, okay? I did not make that blank long enough for me, at least. Hopefully you write better than I do. But you make a tree diagram. And basically what a tree diagram is you start at the beginning, okay? So you're starting at the beginning, and every time we have a choice, you branch for how many number of choices. So if we have 3 choices, you make 3 branches. From there we have 2 choices, you make 2 branches off the end there. And so you see how there's 3 choices for the first one and 2 for the second. And so that gives us our total number of choices, okay? So what is the sample space of flipping a coin 3 times? What is the sample space? How many different possible combinations are there to flip a coin 3 times? And you could try to count these out by going, well, you get head, head, head. You get head, head, tail. You get head, tail, head, and going all the way through like that. But that's going to take a long time, okay? So the easier way to do it is with a tree diagram. And you may have done this before, but basically a tree diagram, you start from the beginning, and you have 2 choices. The first flip, you can either get a heads or a tail. So we're going to get a heads, or we might get a tails. Okay? Our second flip, we have 2 choices again, right? On our second flip, we can either go to heads or tails. But that's the same whether we rolled a heads the first time or the tails the first time. So if we rolled a heads the first time, now we have a heads or tail. If we rolled tails the first time, now we have a head or tail. Then we have, again, a third time, splits into head or tail. Head or tail, splits again, head or tail, split skin, head, or tail. So at the end there, we can see all our possible outcomes. And so we can also look at this by just, so how we find out how many total possible outcomes there are is by counting. Okay, so we can count 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Okay, so there's 8 total possible outcomes, so our sample space is 8. Another way to think about this, we'll get to that in a second, sorry. So trying the other side, flipping a coin twice, and then spinning a 3-section spinner once. Okay, so the spinner is circular and has 3 sections. Okay, so the first coin flip, let's call sections 1, 2, or 3. The first coin flip, you can either get a heads or you get a tails. The second coin flip, you can either get a heads or a tails. Once again, a heads or tails. And then we're going to spin the spinner. And for when we spin the spinner, we have 3 options. You can either get option 1, option 2, or option 3. You can get option 1, option 2, or option 3. Option 1, option 2, or option 3. Option 1, option 2, option 3. So when you count these, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total possible outcomes. Okay? So, these are kind of simple, and you can do them, and they're real simple when we're flipping to coins and things like that. But what if you had to make a tree diagram for 7 different choices 3 times? Okay? So you'd make 7 branches, and then from each of those 7 branches, you'd make 7 more branches. And each of those branches, you'd make 7 more branches. It's starting to get really, really tedious, really, really fast. Okay? And this is where we start getting better at doing this quickly, is by using this next thing. Okay? So, if you look at our choices, this first choice that we did, you could have gotten a heads or tails, right? So you had 2 choices, right? You could either gotten a heads or tails, 2 different choices. On the second one, you had 2 choices again. You could either gotten a heads or tails. So another 2 choices. In the third one, we're spinning a spinner that has 3 sections. So you could have had 3 different possible outcomes. Okay? When you multiply those together, you get 12. Okay, so 2 times 2 times 3 is 12. And so if instead of making a giant tree diagram, in order to count the possible number of outcomes, you can do it like this, where you just multiply each choice. Okay? Come back to here for a coin. The first choice, you had 2 choices. The second choice, it's right here. First choice, you had 2 choices. Second choice, you had 2 choices. Third choice, you had 2 choices. Don't just take my word for it. Actually plug it in your calculator. Actually do the math real quick. You can do it with the math. You don't need a calculator. When you do this, you get 8 possible outcomes. Okay? If we had an example where you had, like the one we were doing before, 7 choices the first time, 7 choices the second time, 7 choices the third time. 7 times 7 times 7 is not only a lucky number. When you do that, you can just plug it in your calculator. 7 times 7 times 7, 343. So this means there are 343 different possible outcomes for this. All right? This method of finding the sample space, this method of finding the total number of outcomes, is the counting principle. So come back over here. Counting principle is method for finding sample space by multiplying options together. Cool. That's the counting principle. So what we want to do now, I'll leave that there so y'all can read it for a second. What our next thing we're going to do is we're going to flip over to the back of this, and we're going to do some of these practice problems together. So, excuse me again. So we're looking at this. We're looking at to try to find. Let me zoom in for y'all. Nice and close. So, move this in. Nice zoomed in for y'all. Okay. So we're looking at this bagel shop. It has 3 types of bagels: plain, onion, and raisin. Okay. Each bagel could be ordered with no spread, butter, or with cream cheese. So if we wanted to do this, we can make a tree diagram. We have plain, onion, or raisin. So for each of our plain, onion, and raisin, we can have no spread, butter, or cream cheese. No spread, butter, or cream cheese. No spread, butter, or cream cheese. So that's 3 options for the first one, 3 options for the second one. 9 total outcomes. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9 total outcomes. Okay? Does that make sense? We can do the same thing for the next one. Softball player bats twice in a game. So they have 2 options. Each at bat results in out, getting on base, or hitting a home run. That's 3 options. And so there's 6 total different combinations that they can have. So once again, all we're doing is we're just counting the number of options in the first one, in the first choice, multiplying it by the number of options in the second choice to give it to us. 2 options in the first choice, 3 options in the second choice. Gives us 6. Number 3, we're spinning a spinner. Spinner can be red or blue. First spin can be red or blue. Second spin can be red or blue. 2 times 2 equals 4, and 8 no more. Number 4, we have a red marble, a green marble, and a blue marble. That's 3 total marbles. Okay. You pick a marble to play with. Okay. So after you pick a marble, this one's tricky. After you pick a marble, how many marbles are left? So like 2 marbles left, okay? So I pick a red marble. That means my friend can only pick between green or blue. So that means after I pick one, they only get 2 choices. That gives us 6 again. We'll talk more about that in a little bit, but basically just thinking about how we're doing it, and making sure that when we pick it, we only pick one. I get distracted. When you're picking, and then someone else picks bat after you, they'll have one less option to pick from. Anyways, moving on. Alright, so these get a little more complicated. We have 7 multiple choice questions. Each question has 4 options. So that means we're choosing between 4 options, A, B, C, or D, 7 times. So it's going to be 4 times 4 times 4 times 4 times 4 times 4 times 4. Okay? What happens when we multiply the same number by itself 7 times? What's another way to write that? It's an exponent, right? So that can be rewritten as 4 to the 7th. Okay, and so instead of having to type in my calculator 4 times 4 times 4 times 4 times 4, I'm just going to come in here. This is way too zoomed in. Sorry. We're just going to say 4 to the 7th. Enter. 16, 38, 4. So yeah, that's how we do it whenever it is multiple things over and over again. Okay? This one, softball player bats 4 times. Each at bat can either be an out, getting a base, or hitting a home run. Okay? And so the first at bat, there's 3 options. The second at bat, there's 3 options. The third at bat, there's 3 options. The fourth at bat, there's 3 options. Okay? And so that's the same thing as 3 to the 4th, which equals 3. Sorry. Can you see that at all? 3 to the 4th. We clear out that 33. 3 to the 4th gives us 81. Okay, so I missed one earlier. Basically, this one up here, instead of being 2 times 3, because there's the first at-bat, you could have had 3 options. The second at-bat, you could have had 3 options. That should have been 9. And so that it was a mistake, and I'm sorry. But, yeah, I got number 2 wrong. I'll say something about that at the beginning of class, hopefully. Moving on, 7 and 8. Okay. When a button is pressed, a computer program outputs a random odd number greater than 1 and less than 13. So, spin on a number. It's greater than 1 and less than 13. This one takes a little more work, so you got to figure out all the options, right? So, let's go ahead and make our total set. So number greater than 1. 1 is not greater than 1. 2 is not odd. We need an odd number. 3 is an odd number greater than 1. 5 is our next one. 7, 9, 11, and then 13 is not less than 13. So that's it. So we got 1, 2, 3, 4, 5 total options. We're pressing the button 6 times, or 5 times 5 times 5 times 5 times 5 times 5, or just 5 to the 6th. We do that. 5 to the 6th. 15, 625. 625. Alright. I want you all to try the rest of them on your own. I will have an answer key in class, so you can look at it and let me know what y'all think and how to do it. And yeah, whenever y'all finish this sheet, work on the USA test prep again, because I don't want to overload y'all with homework, but I think it's really good practice, and so we're going to be doing it sometimes in class, like we are today. And hopefully by this point, I will be done with my class things, like class registration. Anyways, let me know if you had any questions, and yeah, goodbye.